Hello, Miss Walsh here. So today we're going to do day 3 and we are going to do intervals of increase and decrease. Okay, so pretty straightforward. What you need to remember is that basically a function is increasing. When a function is increasing, the derivative will always be positive, as opposed to when it's decreasing, the derivative will always be negative. So here, as you can see, this function is increasing, so you know that here all the derivatives will be negative, okay, as opposed to here you can see that it is decreasing. It's just like in 8th grade. Just think of your slope, okay? All of these slopes and all of these, or another way to say slope, remember it's a derivative, right? Or slope of a tangent, slope of a curve will be negative, okay? So here we need to give the intervals, okay? So then let's do the increasing. And if you want to, remember, pause, try it on your own. Don't watch it like Netflix. Okay, so increasing is this right here. How do we write this? So it's between -1 and 1. So just put -1 and 1, put x in the middle, and so it's bigger than that, and it's smaller than that, okay? Don't put the equal signs, because if you put in the equal signs at -1, the slope is actually not increasing or decrease, right? Remember, the function actually stops. So it's neither increasing nor decreasing at the extrema. Okay. Decreasing, then this is going to be here. So it's going to be x is less than -1. And also all the way here. You don't care about the y values. It really doesn't matter how high the function is. You just care about the x's, okay? So when it's bigger than 1, then it is also increasing. Don't worry about this notation. If you just wrote the word and, or even if you put a comma, it doesn't matter. They're just happy if you get the intervals correct. Okay, so now we're going to do another question, and this one is asking us to interpret a table, okay? So it's giving us two x values from some function. We don't have a function here. This is why I don't have my calculator out here. And it's giving us the f of x, which, remember what that means. That means that these are the y values, right? And then these f prime of x, these are the derivatives. So again, this is the y value, and these are the derivatives. Okay, write down the coordinate at x is 1. Alrighty, well, what's the y at 1? Well, it's 2. It's f of x, right? So you can think about it as f of 1 is 2. So then your coordinate is 1, 2. Woohoo! Okay, is the function increasing or decreasing? As soon as you hear those words, then that's your alert to look at the derivatives. So let's look. F of x at 1, is the slope positive or negative at 1? Okay, it's 4. Okay, so what we can say is, since the derivative at 1 is 4, what that means is that f of x at 1 is for a positive or a negative number? It's a positive number. So that means the slope is positive. That means that the function is increasing. Okay, so just picture a slope of 4 having something like that. That's what's happening. As opposed to, also be careful, they're switching functions in us. We're going to g now. Okay, so now they're asking us, is it decreasing or increasing at 1? Let's look at the derivative. Negative. So what that means is that since the derivative, remember, the slope at 1 is -3, it's negative. That means that g of x is decreasing. Okay. And so now, last part, we need to solve g of x is equal to 2. This is tricky, okay? So think about what this means. Remember, you take a function, and when you set it to 2, when you have something like this, and you set it to 2, then this is the y value, okay? So another way to think about this is, at what x is the y 2? This has to be in the table. You don't have to do any, imagination. Just go to the g of x being 2. The y is 2. Where's that happening? Oh, it's happening when x is 8. Okay, so that means that g of 8 is 2, so therefore this is happening at 8. Okay? So that's it, just a little bit of interpretation. So this is a little bit trickier because here, consider the function. The following diagram shows us the derivatives. Okay, so this is actually not y values. These are derivative values. They're all slopes of some y. Okay, so what that means is like over here, anywhere above the x-axis, the slope is positive. Even if this thing is decreasing, don't look at the tangents, look at the y values, because the y values here, in fact, represent the slopes, okay? So I'm just gonna write this here. So above x-axis, so all slopes, which remember means all derivatives, are positive, okay? When it's below the x-axis, then all slopes are negative. So, where would the function find all possible x's where the value, so what does this say? This say the graph has x-intercepts, so it has x-intercepts. There's a local maximum at B and a local minima at A and at C. But you actually don't care about these minima or maxima because these are for the derivatives, okay? So let's just see for what values of x the original function was increasing. Okay, if the original function, decreasing, then what that means is that all the slopes are negative. So another way to think about it is, where is it below the x-axis, okay? So when you have below axis and all slopes are negative, that means that f would be decreasing. So basically, the answer to our question is that anywhere between 0 and d, it's decreasing. Okay, find the value of x where the graph f has a local minimum. Again, it's the original f that they're asking about. So where would it be a minimum? Okay, just think about what happens at a minimum, okay? When you have a minimum, what you have is you have a slope switch that would go from being a negative slopes to being a positive slopes, okay? What that means that on our derivative function, look for going from below x-axis, from a negative slope, to above. What point does that happen to? Well, let's see. Here, there's no switch. So here the function stopped, but it was positive on the original and still positive. Here, you had a positive slope, and then it switched into being negative slope. So in fact, at 0, you would have a max. And so it's actually right here. What would happen on the original one is you would have some sort of a negative slope, and then after it switches to being a positive slope, okay? So therefore, this is a min. So we're going to say that the local min happens at D because switches from negative slope to positive slope, okay? That will always happen whenever there's a min. Okay, that's it. That's day 3 done. Ciao, ciao.